Hello, fourth grade, and welcome to lesson 7-3. We're going to be working on repeated reasoning in this lesson. So what we're going to be doing here is we're going to think about how can we use repeated reasoning to find all of the factors of a number? What kind of shortcuts and ideas do we have to help us figure that out? Let's go ahead and watch our lesson video. And then we'll get started on our notes and guided practice after that.
How can you use repeated reasoning to find all the factors for a number? A new city park is opening. The gardener needs to select 15 trees from a nursery and plant the trees in a rectangular array. What are all the different ways the gardener can plant the trees? Think. Can I look for a general method to solve this problem? I can find all the possible factors of 15 that can be arranged in a rectangular array. Think. How can I make a generalization from repeated reasoning? I can look for things that repeat in a problem, look for shortcuts, and generalize from the example. Think about the problem. What are all the different ways a gardener can plant 15 trees in a rectangular array? What steps repeat in the problem? Keep dividing 15 by 1, 2, and so on to find all the factors of 15. How might generalizing help you to solve this problem and other similar problems? You can figure out when to stop dividing by possible factors without having to divide by all the numbers from 1 to 15.
That makes the problem easier to solve.
Here's my thinking. To find all the factors of 15, I divide 15 by divisors starting with 1. Then I use the commutative property to write two multiplication equations. 1 times 15 equals 15, and 15 times 1 equals 15. 2 is not a factor. 3 times 5 equals 15, and 5 times 3 equals 15. 4 is not a factor. 5 times 3 equals 15, and 3 times 5 equals 15. I already found the factor paired with 5, 3 times 5, and 5 times 3. When factor pairs start repeating, I can make a general statement, or generalize, that all the factors of a number are found. The gardener has 4 different ways to plant the trees. 1 times 15, 15 times 1, 3 times 5, and 5 times 3 arrays. Why should you stop dividing once you find a repeated factor pair? When the factor pairs start to repeat, you have found all the factors for a number. For example, when looking for the factors of 15, any number greater than 5 would pair with a number less than 5 to equal 15. So, that factor would have been found as a factor with the number less than 5. Now you know how to use repeated reasoning to find all the factors of a number.
All right, let's go ahead and get into our notes and our guided practice. All right, now our notes for this lesson. Again, we have our title up at the top, 7-3 repeated reasoning. And we're going to be thinking about how we can use repeated reasoning to find all the factors of a number. So just like we heard in our video, we're going to look for things that repeat. We're going to try and find shortcuts, and we're going to make generalizations. So one generalization, or just a general statement that's true, that we can make is that when the factor pairs start repeating, that means you've found all the factors of a number. Now, my example that I have for you guys here says Jane bought 24 cubes. She wants to arrange them in a rectangular array. What are all the different ways that she can arrange them? So the first thing you need to do, you're going to annotate your question, circle the important information, underline the question part, and then think, how can I find all the factors of 24? And then try it out. Start with 1 and move on up. So 1 and 24 are a factor. So 1 times 24 and 24 times 1. That's a way that she can arrange them. 2 times 12 and 12 times 2, because 24 is an even number, so that can divide by 2. 3 times 8 and 8 times 3 also make 24. And then 4 times 6 and 6 times 4 also make 24. 5 is not a factor, so we weren't able to use that. And then our next digit was 6. Now we saw that we already used 6. So as soon as your digits start to repeat, you know you've found all of the different factors. So I know I can stop there. So I found out that she can arrange it 8 different ways. These two, these two, these two, and these 2 different ways. Now the factors of 24 we said are 1, 2, 3, 4, 6, 8, 12, and 24. And it's in that rainbow setup that we saw when we were talking about factors. Now I drew it underneath on the side as opposed to drawing it on top. It's the same thing. It just reminds you that you're working from the outside in, multiplying those factors by each other. So I know there are only 8 ways to arrange the cubes because the factor pairs begin to repeat. That means I found all of the factor pairs for 24. Let's go ahead and take a look at our guided practice for this lesson. The first question asks us, what are the factor pairs for 20? Explain how you know you found them all. So what I did was I started from 1 and started working up from there. 1 times 20 and 20 times 1, 2 times 10 and 10 times 2. We know 3 is not a factor of 20, 4 times 5 and 5 times 4. So I went 1, 2, 3, 4, and then 5 would have been the next one, but it repeats over here. I've already used 5. So the factor pairs of 20 are 1 and 20, 2 and 10, and 4 and 5. I know I found them all because after 4 and 5, they begin to repeat. So that way I know that I've already found all of the factor pairs. For number 2, it says find the ways that Miss Maribel can arrange the desks. Remember, she wants to arrange at least 2 rows, but no more than 8 rows at a time. So first, we need to figure out all the different ways she was able to arrange them. So we worked on those numbers already, but we have to make sure we stay within the rules that they put in the question. So there needs to be at least 2 rows. So we can't do 1 and to find 20. We can't do 1 and 20 because there needs to be at least 2 rows. So we took 1 and 20 out. Now we know she can do 2 and 10 or 10 and 2. But again, it tells us over here in the question that she can't have any more than 8 rows of desks. So we're not going to be able to use 10 and 2, but we will still be able to use the 2 and 10. So 2 rows with 10 chairs in each row. She can use the 5 times 4. So 5 rows with 4 in each row, or 4 rows with 5 chairs in each row. So we did have more possible ways to make 20, but we had to make sure that we were following the directions and the clues that they gave us in the question. So make sure whenever you're answering things like this, go back and see if they give you specific information on what you can and can't use. That way you make sure to answer your question correctly. Go back and rewatch the videos, the extra supplemental videos that were put into yesterday's lesson on 7-2. Those will help you again with factoring and finding factor pairs. If you have any questions, let me know. Otherwise, I hope you guys have a great day, 4th grade. Take care. Bye-bye.